Hi, second year students, it's math with AUB. The remaining questions of exercise 4.3 based on homogeneous questions, and we have given initial condition. Initial condition turns our general solution into a particular solution. If we utilize this condition, it will give us the value of C. After putting the value of C in the solution, with C, the solution is known as general solution. With the specific value of determining the value of C utilizing initial conditions or boundary, in that case initial conditions are given, it is known as general particular solution. After the determination of value of C, it is known as particular solution. Without wasting time, question number 12. X times y square, x times y square dy over dx is equal to y cube minus x cube with initial condition y of 1 is equal to, we are familiar, this is value of x and this is the value of y. In the end, we determine the value of C. It is the ratio given to us dy upon dx. Shift this one here, it is homogeneous. Let me give you a good view. Even variables are different, 1 and 2. If they are multiplied, add their power 3. 3, 3, yes, it is homogeneous. Dy upon dx y cube minus x cube divided by x times y square. Suppose y is equal to Vx differentiate, we are going to have something like apply product rule, V same, differentiation of x is 1 and differentiation of V with respect to x is dv over dx. Put both these values in the equation, it turns this equation into separable differential equation. Let's see, dy upon dx means V plus x dv over dx. Y cube means V cube x cube minus x cube. Xm V y square means V square x square. Taking x cube common from the numerator, we have V cube minus 1 divided by, it will become x times x square x cube times V square. X cube cancel out. We are left with V plus x times dv over dx is equal to V cube minus 1 over V square. Shift V on the right hand side. X dv over dx. Already V cube minus 1 over V square we have minus V. Taking LCM, V square is LCM. It will become V cube minus 1, V square into V. It will become V cube. Cancel it out. We are left with x times dv over dx minus 1 over V square. Now it is a separable differential equation. Shift. We need neither dy in denominator and dx. We need both of them in numerator, not in denominator. dv is already in numerator. Shift dx towards right hand side. Mathematically, we are going to have such thing minus 1 over v square times dx over x. With dx, x term suits. With dv, we shift v square here. It will become negative v square dv dx over x. Let me check what sort of frame I have been left with. Still, I can write a step also here. Integrating with respect to their independent variable minus v square dv dx over x. Its integration is given by v cube. Add 1 into the power of v cube over 3. It's ln x plus c. Ln x plus c. What is the value of v? From this, re-put the value of v. It will be y over x. It will be y over x. It will be y over x. Utilize here. Minus 1 over 3. We have y cube over x cube is equal to ln x plus c. Now, if we left the answer here, if we would haven't given this condition, then this is our answer. It is known as general solution. Determine the value of c utilizing the initial conditions. Value of x is 1, value of y is 2. Put in that equation and you are going to get value of c. How? Let's see and find out. minus 1 over 3 y cube over x cube is equal to ln x plus c. ln x plus c. Value of x is 1. This is value of x. This is value of y. Value of x is 1. Value of y is 2. Y is to 1 over 3. Y means 2 cube divided by 1 cube. It is ln 1 plus c. ln 1 is equal to 0. We are left with minus 8 cube over 3 is equal to c. That is value of c. That's value of c is minus 8 over 3. Here, put here. It will become our particular solution. Putting the value of c, we are going to have minus 1 over 3 y cube over x cube is equal to ln x. C means minus 8 over 3. C means minus 8 over 3. Shift 3 here. We are going to have y cube over x cube minus, it will become 3 ln x minus 8. Minus 8 in that case. Minus 8 in that case. Minus 8 in this case. I'll shuffle them on one side. I'll leave here. It's our answer. So finally we have multiplying by minus y cube minus x cube minus 3 ln x plus 8. Leave here or take them in any other side. If that is the solution, this is known as general solution because the value of c is not determinate, it's indefinite. If we utilize the initial condition, in that case we have given y of 1 is equal to x is equal to 1, y is equal to 2. If we determine the value of c and put here, and it is going to be our particular solution. Particular solution. Okay. Question number 30. Question number 13, that is x square plus 2 times y square dx is equal to xy dy. First, prepare the ratio dy over dx. Shift dx here, xy here. We are going to have something like x square plus 2y square divided by xy is equal to dy over dx. Again, switch over to the assumption that make homogeneous differential equation to convert it to separable differential equation. Suppose y is equal to vx. Don't forget to differentiate with respect to x. It is v plus x times dv over dx. Utilize both these suppositions. In the original integral we have, instead of dy upon dx, I am writing v plus x dv upon dx. It is value of dy upon dx. I am writing first dy upon dx. This side here x square. Y square means 2 times v square x square divided by x times vx. Taking x square common from numerator, we have 1 plus 2v square. Similarly, x square v in the denominator cancelled out. We are left with v plus x dv over dx is equal to 1 plus 2v square over v. Shift v on the right hand side in a usual fashion. X dv over dx is equal to 1 plus 2v square over v minus v. Take LCM. Nothing there. 1 is always there. V 1 plus 2v square minus v square. We are left with 1 plus 2v square minus v square, 1v square over v. Now make it separable differential equation. X times dv over dx is equal to 1 plus v square over v. Shift v and 1 plus v square on the left hand side, dx upon x there. Mathematically, we have v over 1 plus v square is equal to v over 1 plus v square dv is equal to dx over x mathematically. It is in division, it is in multiplication here. Integrate, simply integrate, and it is going to work wonderful. Wonderful. Let me make a space. Oh. Yes, integrating with respect to independent variables, v plus dv over 1 plus v square, it's dx over x. It is a situation of ln x plus c. Here, there's deficiency of 2. Differentiation of v square is 2v. There's function having overall power 1 and differentiation in the numerator with deficiency of 2. We can compensate by dividing and multiplying 1 over 2 v dv over 1 plus v square. It's all ln x plus c. It is 1 over 2 ln 1 plus v square is equal to ln x. Look here, ln, just fix the constant having ln. Tiny property of log, it will become ln 1 plus v square. Under root means 1 square. Coefficient can be converted to power of log. It is ln x. Let me introduce instead of c ln c1 constant. We can merge log and easily we can get rid of ln. ln 1 plus v square. It is ln x times c1. ln x times c1. Okay, ln cancel or taking e both sides. Taking e both sides, we are done with. We can easily get rid of ln. We put the value of y, v. We put the value of v, that is v over x. There is v square, y square over x square is equal to x times c1. Taking LCM, it is x square plus y square over on x square. We have x times c1. X square is a perfect square quantity. It can be written as x square plus y square over x is equal to x times c1. Shift x here, it will become x square plus y square x square times c1. Shift this quantity here. Now utilize the initial conditions that we have. Y of 1 is equal to 1 to make this solution a particular solution. Both are 1. 1 square plus 1 square is equal to 1 square c1. So c1 is equal to under root 2. C1 is equal to under root 2. Our constant is under root 2. So our particular solution is going to be something like this. Here, put value of c. X square, y square, x square times under root 2. That's our answer in that case. That's our answer in that case. Look, the flexibility of a constant. There is c, I have written ln c because we can merge ln, here is ln, and we can easily get rid of ln. Don't you worry about that constant. Constant can be managed in any way in differential equation. But sensible one. Moving towards next question. That's I think 14, second last. 2x square dy over dx plus 3xy plus y square. And the final question, having question number 14. 2x square dy over dx is equal to 3 times xy plus y square. We have already ratio of dy over dx. Just shift 2x square in division towards the right hand side. Dy over dx is equal to 3xy plus y square dividing by 2x square. Suppose y is equal to vx. In order to convert homogeneous to separable differential equation by using this substitution, differentiate dy over dx, apply product rule here, v times 1 plus x times dv over dx. Product rule, manage both these values here, plug in v plus x dv over dx, 3 times x, v, y means vx plus y square means v square, x square divided by 2x square. A tiny manipulation, it will become 3x square v plus v square x square divided by 2x square. Taking x square common from numerator, we are left with 3v plus v square over 2x square. X square definitely cancelled out. Now just shift this v on the right hand side. Then we are in a position to make the equation, differential equation a separable one. V plus x dv over dx. What we are left? 3v plus v square divided by 2. Shift v here. It will become minus v. We are left with here x dv over dx. X dv over dx. Taking LCM. To LCM we have 3v plus v square minus 2v. 3v minus 2v, we are left with only v. We have v square plus v over 2. V square plus v over 2. Now it is a separable differential equation. Separate them and integrate. Separate them and integrate. Let's see how. Here. Finally, we have x times dv over dx. V square plus v over 2. Shift dx over x here and v square plus v towards dv. We have dv over v square plus v 1 upon 2 here dx over x. Integrating with respect to their independent variables. 1 upon 2, it's a constant dx over x. It is situation of ln. Look at this. It is no function derivative situation. Take v common. It is a simple case of partial fraction. 1 over 2 ln x plus c. Here, apply partial fraction. It can be written as a over v plus b over v plus 1 dv is equal to 1 over 2 ln x plus c. Now take this portion and take a partial fraction. Determine the value of a and b, put here and integrate. We have for partial fraction, I am taking that tiny portion that to be solved to integrate. It is a over v plus v over b over v plus 1 is equal to 1 over v times v plus v. Taking LCM, v times v plus 1, it's a v plus 1 plus bv is equal to 1 over v times v plus 1. If I shift this v times v plus 1 towards the right hand side, they are cancelled out. I am saving my soul and cancelling here. Just multiply av plus a plus bv. In order to compare, we have only constant. Introduce 0v plus 1. Collect the like terms. Av plus bv plus a is equal to 0 times v plus 1. Now, constant is equal to constant. Value of a is equal to 1. Taking v common from this, v common, we are left with a plus b. That is equal to 0v. That's equal to 0v. V cancel out. We have a plus b. Just compare the coefficients. Coefficient of v is equal to v. That's 0. Constant is equal to constant. We have already a. So a is equal to minus b. A is equal to minus b. Okay, put value of a here. 1 plus b is equal to 0. So b is equal to minus 1. Fix both these values here. A 1 b minus 1. Then integrate. After that, still c is lingering along to be determined by the initial condition. A is 1 1. Means it is 1 over v dv. B is minus 1 minus dv over v plus 1 is equal to 1 upon 2 ln x plus c. It is situation of ln v minus ln v plus 1 is equal to 1 upon 2 ln x. Look at this. Ln, another ln. So constant must be parallel to them. Let me introduce ln c1 in order to merge them and get rid of ln. Deviant subsection separate ln can be written in the denominator as v over v plus 1. Tiny property of logarithm is equal to power. Coefficient can be converted to power. It will become ln under root x and it is ln c1. Merge them. Ln v over v plus 1. We have ln under root x times c1. Taking e as a base, ln cancelled out. Apply the initial condition. In that case, x is 1 and y is minus 2. X is 1 and y is minus 2. X is 1 and y is minus 2. Let me write specific x is equal to 1 and y is equal to minus 2. What is my final answer? Still I have to manage the value of y here. We are left with v over v plus 1. I am in haste to put the value of x and y. Still there is no x and y. Re-put the value of v. We have assumed that y is equal to vx from the v is equal to y over x. Put here. It will become y over x divided by y over x plus 1 is equal to under root x times c1. Just take LCM. Y over x y plus x over x. X cancelled out. We have under root x plus c. We have something like y over x plus y is equal to under root x plus c. X is 1, y is minus 2. It is minus 2 over 1 plus minus 2 is equal to x means 1 plus it is x times c. It is in multiplication. We have utilized x times c1. Now, what is value of c? C is minus 1. Let me check. Minus 2 divided by minus 1 is equal to 101 means 1, C1 cancelled out. So my C is constant is 2. My constant is 2. It's my answer here. We put here. It will become y over x plus y is equal to root x. C means 2. C means 2. Or one can write y over x plus y 2 times root x. It's our answer. It's our answer. It's our answer. Moving towards final question. Moving towards final question. It is a which one it is? It is 14 number 2x square, that is y over x plus y whole square. There is no x. Okay. Here we have arrived at the result y over x plus y is equal to 2 times under root x. In your book, this side has a square, this side has a square, x hasn't a square. Squaring both sides to get your answer y square over x plus y whole square. It will become 4x. Your question answer has been written in that fashion. Y over x plus y overall square. It is 4x. It is 4x. From where comes or occurs this transition? We have done here ln. We have something like this 1 over v square plus v. We have shifted 1 upon 2 towards ln x. If 1 upon 2 would have been there, if 2 I haven't shifted there, then there is direct square. Then there is direct square. It's okay, it is nothing. I am giving you the way here. If I wouldn't have taken 1 over 2 here, I have written direct your answer. But both answers are equivalent. This is and this is, they are equivalent. I have just shown you the equivalence. Equivalence. Whatever you want to do, just do it conceptually. You are going to arrive at a good result. We have left here. It is not incorrect. It is not incorrect. If you compare this one with your book, squaring both sides, we have y divided by x plus y whole square. Square of 2 is 4 and root is no more. We have 4x. We have 4x. We have 4x. It is leave here or here. I have shown you the equivalence. I have shown you the equivalence and quality and mystery of myself that it is not incorrect. I have done something wonderful for you. Question number final one. Final one. X plus y times e raised y over x times dx minus x times e raised y over x dy. First, get ready the ratio. Getting ready the ratio, shift this quantity here. We have x plus y times e raised y over x dx. It is x times e raised y over x dy. Shift dx here and this x times dy x here. We have something like this: x plus y times e power yx divided by x times e power y over x is equal to dy over dx. Same supposition, y is equal to suppose y is equal to vx. Differentiating both sides, dy over dx, v plus x times dv over dx. dv over dx. They put both values here. X means x, y means v times x. E y over x, y means vx divided by x, and x is no more. We have x, y means vx over x. and x is no more, is equal to this dy upon dx is equal to v plus x times dv over dx. Let me write in proper fashion. We are left with x plus v times x e raised v over x times e raised v is equal to v plus x dv over dx. Taking x common from the numerator and cancelling out x common, we have 1 plus v times ev divided by x times e raised v is equal to v plus x dv over dx. Cancelled out. Cancelled out. Okay. Shift v here. Shift v on the left hand side in that case. We are left with 1 plus v times ev over e raised v minus v is equal to, we have dv over dx, x times dv over dx. Let me manage my writing. It is going to be a snail crawling. Okay. We have 1 plus v times e raised v over e raised v minus v. I am writing this step again for you in order to improve my writing, handwriting. Taking e raised v LCM, 1 plus v e times, it will become minus v times e raised v is equal to x times dv over dx. Cancelled out. We are left with 1 over e raised v is equal to x times dv over dx. Separating the variable, taking ey here and this one here, it is dx over x. We have e over v dv. Integrating with respect to their independent variables, we have e raised v dv. Integration of 1 over x is ln x, e raised v same plus c, ln x, e raised y over x plus c. That is our general solution. What are initial conditions? X is equal to 1 and y is 0. X is equal to 1, y is equal to 0. Utilize here ln 1 e raised 0 over 1 plus c. Ln 1 is 0. Any quantity having 0 power, any non-zero quantity having 0 power. It is exception. 0 power 0 is not equal to 1. It is exception. A non-zero quantity having 0 power is equal to 1. A non-zero. 0 raised 0, it is indeterminate form. 1 plus c. Shift 1 here. Minus 1 is equal to c. So value of c is minus 1. Putting here, and it's our answer. And then x is equal to e raised to y over x. C means minus 1. C means minus 1. So we have just compiled our exercise 4.3, 4.3. The next are the pure applications of differential equation. Inshallah, we are going to get them as well. It's all by itself next.